let me share screen. If you have your textbook, it will be helpful because your textbook has all the very helpful information. This one. All right. So in your textbook, if you read your textbook diligently, you will have all the things that you have been finding out, reading up on SLS, as well as putting onto your Google Classroom about the four-sided figures. Right. So if you have been Googling, and you might be able to find things like this table here. Let me just close this. Check this out. Okay. You might be able to find a table that looks like this. They ask you to discuss and compare the properties of the quadrilaterals. How similar or different are they? Okay, this word itself is already a bit like a tongue twister. Quadrilaterals. Lateral means side. Quad is four. Quadrilaterals means it's a four-sided figures. Now there's this. These are all the properties that we're supposed to remember, memorize, and these properties are like, for example, all sides are equal, opposite sides are equal, one pair of opposite sides are parallel, two pairs of opposite sides are parallel, four right angles, opposite angles are equal. That's like 6 things to memorize. And being able to identify correctly which shape has which property and which properties, which shapes are similar becomes very important in from now to even you're older. At secondary school maths, you still need to know these properties. And it gets more complicated in a way. Now, you might be able to by Googling. This keyword that I type in is called map of four-sided figure. Now, what it means is this, is that you will see things like this, four-sided polygons. Polygon is the word that you learn in secondary school. Polygons means it's a big term for all kinds of shapes. Okay, we will learn in secondary school about that. But what happens is you realize that there seems to be some kind of a hierarchy, like like a family tree. Who's a dad and who's a mom and who's a grandpa, and then after the aunts and then so and so. It's like a family tree in a way. So you have this thing called the quadrilaterals, and you realize that it goes branching downwards. Now, another example is this one. Is like this is a cleaner example. And you realize that, okay, what happens is as more properties are added in to specify the shape, it gets to a different name. So, like for example, all four-sided figures are called quadrilaterals. As long as the shape has four sides, it's called quadrilateral. If the shapes start to have, for example, on this line here, okay, you realize that, let me highlight this in pink. You start to have, like, say, a properties of sides being opposite sides being parallel. And then you realize that, okay, there's a branch out here. So this particular four-side figure does not have parallel sides. It does not have any side that's parallel, but it has another set of properties, the kite. The kite is a shape that you learn next year. But when you start to have properties of parallel, then you start to have different names of the shape. Here you have parallelogram and trapezoid, or trapezium. When you add another property, the shape changes. So if you look at it here, you recognize that the parallelogram is the bigger umbrella. Such that if the parallelogram has a right angle, the parallelogram is now known as a rectangle. And if the parallelograms have all four sides being equal, it starts to become a rhombus. If the parallelogram starts to have all four sides equal and also a right angle, it becomes a square. So it's like a hierarchy of shapes. If you look at your textbook and what you have revised on the SLS, here's the few shapes that you need to be drawing later on. Now, then on Wednesday, I was trying to help friends and back to remember this trick called the equal sign. So if you put your two fingers out, okay, of course, it doesn't look very equal now. Probably need to put up two other fingers. But let's say I put it as an equal sign here. If you look for equal sign, you decide. For example, this is the trapezium on your textbook. I look for the equal sign, say, here. So this equal sign shows you the property of parallel lines. If there's one pair and only one pair of parallel lines, that means there's only one set of equal. That means this shape is a trapezium. Only one pair of parallel lines and nothing else is the same. That's likely a trapezium. If, say, you can find two pairs of parallel lines, meaning you can see two equal signs. So here, this is one equal sign. And then you will rotate the shape, you'll see another equal sign here. Meaning it has two sets of parallel lines. Two equal signs that you can identify from the shape, that makes there is likely to be a parallelogram. If you can find two equal signs, for example, here, this is one equal sign. Maybe I can put my finger to it and say, then, this is an equal sign. And you can identify another one on the other opposite side, another pair of parallel lines. So two sets of equal signs. And then one additional criteria, that is all four sides are equal. Once it fulfills these three properties, it is definitely a rhombus. Can you understand that? So I'm starting off with this shape with the idea of parallel lines. And that's the challenge. When did you first learn parallel lines? Primary 3 actually. You learn how to draw parallel and perpendicular lines when you're primary 3. But do you remember how to do it? Using a set square and ruler. So that's our challenge today. We'll start with this with one strip each to try out. This is a strip of a paper that I cut out of the LE3 size. If you're unsure, you can do it as a pair. You can get help from your friends to measure. So you need a ruler and set square, set protractor, center eraser. I feel one strip each first, and let's try working on it. You can check with your friends if you are like not sure whether you did it correctly. Okay, I'll stop sharing here. I'll go on talking about all these long properties mentioned in the book. Okay, it's in your text, so you can refer to the textbook for it. Right now, let me put this up on a big screen. Yeah, test. Okay. Right, so I have my strip of paper here. It's a long strip. I'm going to try to draw a few shapes. Take out my set square, protractor, and ruler. Make sure you have these items, and we're going to start off with the shapes in a specific order. Okay, starting with the first set, we're going to measure the width of this strip. It's about 3 centimeters long, wide. Can you check if it's yours? I tried my best to cut it into a width of 3 centimeters. Okay, the first shape that you need to draw is this. Now, the first thing that I'd like to tell you is this, is that, is it not? Is it not? How long is yours? How wide is yours? As much as possible, I cut it to like 3 or 3.1 to 3 centimeters. 3.2 is more or less like 3 or 3.1, 3.2. Okay, now the first thing I'll share with you is that I try to cut and make sure that it's like a stack of equal sign. Are you going to find the first equal sign here on this strip of paper? Yeah, so that's this one. I'm highlighting this side. This is the first pair of equal lines. I just colored it in pink. Yeah, yes, like Shari is saying, this whole strip itself is like a long rectangle. So this strip already allows you to have 2 sides of the 4-side figure drawn. In this case, I provided the first pair of parallel lines, which I highlighted in pink here. Now, so this is 3 centimeters wide. I'm going to write it here as 3 centimeters. If yours is 3.1, you can write it as 3.1. If yours is 3.2, you can write it as 3.2. So I'm going to write it really tiny here. Mine is 3 centimeters. Now the first shape I'm going to try to draw is a square. Let me show you once. I take my ruler. As much as possible, I make a mark at the bottom of the paper, making sure it's accurately at maybe about 3 centimeters here. I want to make sure there's a right angle, so I put my set square on it. And from here, I can draw a straight line up all the way because it is a set square placed against my ruler. It will definitely be perpendicular lines. To be very sure, I put my ruler on the other side and make sure it's 3 centimeters. And I get my right angled square corners here. Right angle corners, all 4 corners are right angled. And you realize that I measure all sides are 3 centimeters. The first shape I got here is a square. You can also say it's a rhombus. It's a rhombus that has right angles, accurately known as a square. Why is it also known as a rhombus? Because it fulfills the property of 2 equal sides. So this is the 2 equal sides. I can turn it around and see this is another equal side. So these 2 lines are parallel in yellow. These 2 lines are parallel to each other. So the yellow, one set of parallel lines. And I turn it around in pink. This is another pair of parallel lines. Because all 4 sides are equal at 3 centimeters around, it fulfills the criteria of being all sides equal, 2 pairs of parallel lines, therefore rhombus. But on top of that, it has right angled corners. So a rhombus that has right angled corners is a square. Okay? Now the next shape I'm going to draw is going to be a trapezium. Why is it a trapezium? Let's find out later. Again, it's a four-sided figures, and already I have a pair of parallels that's given. There's this colored in pink. Now, a trapezium is that I have only one criteria to this shape. There is this pair of equal sides. For it to be a trapezium, yes, one pair of parallel lines, and none of the sides are being equal in length. So I can randomly draw a line across. Say, for example, like this. Very randomly, I drew this line across. I can cut at any angle. And you realize that this pink line is the only parallel pair of sides. And certainly this yellow line here and this slanted line here definitely are not parallel to each other. But I'm able to measure it. So here I have this yellow line here. It says here 3 centimeters. It shares the side with the square. So it's 3 centimeters. It shares the side with the square. The top here I draw so randomly, I don't know how long is it. Let me just measure it. It turns out to be 2.5 centimeters. I drew it very randomly. And the other side, I drew it very randomly, like just cutting it across. It is about 4.7. Mine's about 4.7 centimeters. How long's yours? Okay. We all will have different measurements, and that's totally okay. And then the other side here is very random. It's also just really, really, really random. It's about 3.8 centimeters. Yeah, so random that it's like I just cut it across, that's all. So as you can see, this shape here, one side is 3 centimeters, one side is 2.5 centimeters, one side is 3.8 centimeters, and this side is 4.7 centimeters. None of the sides are equal in length. Yeah. So this shape here, there's only one equal side, and it's one pair of parallel lines. Here, the pink one. It's called a trapezium. Trapezium. A trapezium. Now, another interesting thing about this shape is that if I measure the angle here, this is 90 degrees, we already know that. This is 90 degrees, you already know that. It's a square corner. Okay? And I measure this angle here. Mine's about 50, 54 degrees. Here's about 54 degrees for mine, this angle. And the other side here, I measure is about 126 degrees. thereabouts. 126 degrees. Can you measure these two angles? Let me just double check it. If it's not long enough, you see what I did? I just take my set square or my ruler and I try to check out that line here. Yeah, see, this is how I do it. I make that line touch by extending this line here with my set square. All right, to help you be able to see clearly, I'm gonna shade this in orange. So this is orange and this is a yellow line. Clearly, these two lines are not parallel to each other. Okay? Do you notice what is happening here? So for a trapezium, you have the pink color pair of parallel lines. All sides are not the same, but there's one additional interesting property. Look at these two angles. 90 plus 90, what is it? 180. 126 plus 54. 180. You discover that? What is yours? What are your two angles? What? Does your two angles at these two corners add up to 180 as well? Yeah, you calculate, okay? You realize that, what do you think about this angle plus this corner angle plus this angle, and so plus this angle, altogether what do you think? 360. So there's two additional properties in four-sided figures. If we add up all the corners in this four-sided figure, you get 360 degrees. If we add the two opposite angles between the equal sign, between the set of parallel lines, it gives you 180 degrees. So this is a trapezium. The next shape we're going to try draw is now, and so you're talking non-stop. You like to take over here. Now the next shape we're going to draw is a parallelogram. So the first property here is still this pair of horizontal pair of parallel lines. Now, for a parallelogram, it has to have two pair of parallel lines. That means I should be able to draw another orange line that is parallel to this one here. That means another side here. And the angle must be 54 degrees at one corner and 126 degrees at one corner. And the length is 3.8 centimeters. Okay? So I can draw any. So what I can do is I set my ruler here on this side here. I put my set square here along this side. I put my ruler. So I put my set square with the square corner here against the orange side I set my ruler against the set square and I can slide my set square along the ruler. What do you think is the purpose of doing this? So that I can start here as well. It's better to start at the tip of the set square. I set my set square against the orange side, put my ruler at the bottom, and I slide up. I can stop anywhere along the ruler as I'm sliding my set square randomly as I wish to stop randomly. Just make sure it's parallel accurately. Randomly, I stop. Randomly, I draw. Right, I thicken this a bit. I make sure that I check. Here is 3.8 centimeters. Yes, that's accurate. I draw another side that's 3.8 centimeters. And I draw an angle here. Yes, this is 54. And here, should be accurately 126. Let me just confirm it. I'm quite good at this. Quite accurate. So indeed, here is 126 degrees. But the interesting thing is that for this shape here, it's like I said, it's like a slanted rectangle. This side is 4.8. And this side is 4.8. This side is 3.8. And you realize that, okay, I color this side orange because it forms the other equal side. See? This orange side is 3.8 centimeters. This orange side is also 3.8 centimeters. That's the same length. And it forms the same angle, 54 degrees. 54 degrees here, 186 degrees. And then it's parallel to each other. This shape here is called a parallelogram. Because you have two sets of parallel lines. One is in pink, one is in orange. And the opposite sides are equal. And so I'm going to take your strip and then show it to everyone later. It should have been as accurate as mine and all the writing on top. And you can see that the pink side here, 4.8 centimeter, is equals to the other side. So I have two sides equal. And these two sides are also equal, 3.8, 3.8. So it's like a rectangle, but a slanted rectangle in a way. What do you think is this angle here? According to mine, my drawing here. What do you think is this angle here? Yes, right? How do you know that? Yeah, it's parallel. So you can see that, first of all, this is the previous chapter. Yeah. Yes. Oh, that's the current one we are learning. The opposite angles are equal. The other one is angles on the straight line, remember? Yeah. So you realize that this one will also be 24 degrees, which is opposite angles are equal here. See? Now the next shape I will draw is a rhombus. Rhombus means, so all sides are equal. So this side, so this is 3.8, right? So again, you see, are you okay with the three shapes so far? Is it difficult to draw? Okay, yeah. So this one, the rhombus states that all four sides are equal. I have the side here that is 3.8, meaning I should draw these two pink color lines. It should stop at 3.8 as well. So I'll draw 3.8 here. Three point eight here. So this side should be 3.8 centimeter, 3.8 centimeter on this side. And you realize that I join these 2 points here. It is also 3.8. I must say I'm quite good at this. I'm very accurate. Yay, comes with practice. I hope you are able to become as accurate as well. So all four sides are equal, 3.8 centimeters, all four sides. And you realize that it has the same properties as the parallelogram. Everything's the same as the parallelogram. On top of that, yes, all four sides are equal. So it says two pairs of parallel lines, the pink and the orange. That means I can put my finger and see there's two equal sides. On top of that, all four sides are the same. 3.8, 3.8, 3.8, 3.8, or on top of that, yes, and all the other exact same properties. Opposite angles are equal. Sum of angles in a four-side figure adds up to 360 degrees. You add up the opposite corners of the angles between the pair of parallel lines, it will be 180 degrees. This is called a rhombus. And this is like echoing the first shape, the square. But it's like pushed to make an angle with the paper. Now this is my first practice of drawing the four side figures, all the way from starting from square. The only shape that I have not drawn is rectangle, that's right. Oh, that's the other one. That's called the kite also. But we're not showing, we're not learning kite this year. You can't really say diamond. Diamond is actually not a mathematical shape. Just like heart shape. What a heart shape is? Uh, it's actually not very accurate to say what say diamond. Let me just let right now. Let me just quickly show you. Okay. Like for example, you say heart shape, right? Heart shape. It looks like this, something like that. But you realize that it doesn't really quite have proper definite property. See, this is, we can also say this is hard. We can also say this is hard. You can also say this is hard. It's not really, then you have a human heart shape. There's a human heart. So this is how the shape really looks like for a heart. So actually, it does not have a real maths property. So a heart, the term heart shape is more English than maths. So let's say you say diamond, a diamond. Right. This is what a diamond looks like. Shining, glittering, shimmering diamond. So you can't really say it's a diamond. So if you say like diamond is like maybe like that, the shape, and you realize that you have many shapes that can form a diamond. Diamond shape is more like an English term. But you may have heard when you are like in primary one or when you are in kindergarten that some of the adults teach you diamond like this is diamond. But actually that's not really a mathematically accurate shape. It looks like a rhombus, it looks like a rotator square, but actually it's not what diamond is. Okay? Diamond is, to be more accurate, diamond is like a English word. Okay? Well, just now what again, kite shape is not really a kite shape, but in geometry, it does exist as some property. You will learn this next year, primary 6. This is the other four-sided figures that you will learn. It is a bit complicated. You realize that it's two isosceles triangle pieced together. Yes, it's more complicated than the one we are learning now. Okay. So right now we have just got 4 shapes. Remember 5 to be accurate: square, rectangle, trapezium, parallelogram, rhombus. And the one that we have not drawn is rectangle. Hold on, got another 4 more minutes to go. Now I'm going to go in reverse now. You're gonna practice more, So from the rhombus, I'm going back to a rectangle. Okay, how do I do that? I've got just 4 minutes left. Maybe you answer this question first. How do you suggest I from this rhombus? I've got 2 sides here. I go back to a rectangle. But I haven't drawn a rectangle yet, right? How do I get to a rectangle from here? How about like here? So I chop it out. But I only want 4 side figures. Yeah, but I made a triangle. Okay, but good idea from Ethan. He says I can change this shape next to a rectangle that I want by drawing a triangle first. That's possible. But I insist that we must have 4 side figures. Which is not wrong. I can cut off here, make a right angle. That's a triangle. Because 3 sides, right? 1, 2, 3. And then from there, okay, so Ethan says I can draw a triangle first. I make a right angle here. I get a triangle. Then I form a rectangle after that. That's a good idea too. My rectangle can be here. Let me have a 5 centimeter length long rectangle. I decided to take Ethan's suggestion. It's a good suggestion. I draw a triangle first. Okay. According to Ethan, I draw a triangle first. I chop this part off here with a corner that's right angle. Let me check with this right angle. I mean, it should be quite accurate thus far. In my set square, yeah, is right angle. So I can use my right angle and then chop off here. And then I get a triangle. This is a triangle, 3-sided figure triangle. And from this triangle, I make a 5 centimeter square that follows after here. And this end here, a 5 centimeter as well. And here I can make a rectangle as suggested by Ethan. Which in fact, yes, very accurately, 4 corners, 4 right angle corners. This is 3.8, 3 minute. Let me measure it. It's about 3 centimeters. But my slip of, I realized I didn't cut it that accurately. It's about 3.1 centimeter actually. 3.1 or 3 centimeter. This 3.1 centimeter. And I've got 5 centimeters on the long side. Hold on, one last question. So I took Ethan's suggestion by drawing a triangle here, and thereafter draw a rectangle. Now, Ethan, what shape do you think I'll get if I combine this triangle and this rectangle? Trapezium, that's correct. Very good, excellent. Yes, please go. Thank you, Sam. Can you understand that? So I combine this triangle with this rectangle, I can get a trapezium. I would like you to go home and try to draw a few more. So from my rectangle, I can move on to a square. From my square, I can move on to another trapezium. From the trapezium, I can move on to rhombus and parallelogram. Can you understand what I'm saying? Yes, can. Now, I would like you to go home and practice drawing these 4 side figures using this strip of paper with different measurements. I got more paper here, if you like. Anybody wants more practice? Because I'm going to end here.